chapter 10 is called Graphs Good and Bad. So it's all about looking at different types of graphs. Specifically, we are going to graph categorical variables. And we're going to look at the different graphs, how to describe them, how to look for trends, and what things we should avoid. So in this example, we talked about this in class a little bit, but graphs are helpful for displaying information in a nice, pretty visual way for readers to see. And we talked about, let's see, this first pie chart there. And we said, well, let's say we were trying to do a presentation on why we need suicide prevention programs and, mental health programs for like high school kids or for younger grades. We would use our reasoning because we see suicide is the cause of death for 15% of the deaths that occur from age 1 to 24 years old. So it's pretty high there, especially when you look at it compared to the other ones. So 25 to 44, this in chart 2, you see that's 11%. 45 to 64, I don't even see it on there. And I don't even see it on the 65 and over. So it's just kind of this for those younger grades or those younger ages where, suicide is even on the pie chart. So if you were trying to do a presentation on, why a suicide prevention program is needed, a chart like this or this kind of pie chart would be able to kind of nice, cleanly display the information for your readers to help you defend your case. That's one of the things that pie charts and charts and graphs in general are good for. So there's a few things that make a good table, make a clear table, and even graphs. You need to have a title. Graphs need to have a title. Tables need to have a title. They need to have clear labels, and they need to have the source of the data should appear as a footnote or kind of like at the bottom of the chart. You should always cite where you got your data from. Otherwise, people don't take it seriously. For our first chart, table 10.1, we have our title up here. So it's the education of people aged 25 years and over in 2017. So we have our title telling us what this is about. Now our labels are going to go here. And my chart didn't copy over very well, but the labels are in your slides online. So the first part is the level of education. Then we have the number of people. This is in thousands. And then our last column is percent. These labels are all in yours. It just didn't transfer over to mine. But we see, we have our title, we have our labels. Down here at the bottom, that is our source. So we have our footnote that has our source. We got our data from the Census Bureau in 2017. Now, oftentimes rates are used instead of counts. So rates would be a percent or a proportion. You see that our chart on the previous slide, they gave the number of people and then they gave the percent. Percents often give like a nice clearer view of numbers. The distribution of a variable tells us what values it takes and how often it takes it. So we're looking at the distribution of our data. We're looking at, what percent of the individuals from the previous example, what percent had a high school graduate, were a high school graduate, what percent had less than high school graduate, what percent had a bachelor's degrees. Those are your distribution of variables, those percentages. Sometimes you have round off errors in your charts or your tables. It's not uncommon. It happens and it's totally fine. For example, let's say we were doing table entries and we were rounding like to the nearest whole percent. So we might find that when we add up all of our percentages, our sum may total over 100%, like 102, or maybe they're 99%, so they're less. And it's just based off just kind of how you round. We always want to make sure we're rounding correctly, of course, but sometimes that, rounding up or rounding down may lead to like a round off error in our chart. That's totally fine. Remember, we have two different types of variables. We have our categorical variable, which places our individual into, groups or categories. Then we have our quantitative variable, which those take on numerical values for which, arithmetic operations make sense. They are numbers where we can it makes sense to find the average of those numbers. For instance, height and weight, it makes sense that we could find the average height or the average weight. So the level of education data that we had in that table, so it's a categorical variable, but there are 6 possible values of a variable. So everybody in the whole, like in the United States, can go into one of those 6 categories. If you never graduated from high school, you go in the less than high school category. If you have like a PhD, you got your doctorate, you're in the advanced degree category. So for this case, it makes sense that we are able to kind of picture this distribution in a pie chart. Now, some notes about pie charts. Pie charts show a whole that is divided into parts. So you have to have a whole that you're dividing into parts in order to make a pie chart. Which, you're drawing your circle, the circle represents the whole, the wedges within the whole represent the parts. And we talked about how to figure out how to find the exact angle measure that you would use. So remember, an entire circle is 360 degrees, like the angle in an entire circle. So if we wanted to say, what is the angle, so what is the degree for, let's do the high school grad. So what we're going to do, we're going to take 360 degrees and times it by our percent. So for less than high school grad, it was 28.8%. But when we write that as a decimal, it's going to be 0.288. So we're going to do 360 times 0.288, which gives us 103.68 degrees. So that pie slice for less than high school would be 103.68 degrees. Now, we can also make a bar graph for that same data. So this shows the bar graph for the educational level data. And so you see with bar graphs, sometimes it's easier to compare because they're all like you're comparing the heights. So you can like quickly kind of compare heights. So some notes about bar graphs. Bar graph displays a single number representing each category. The height of the bar represents the number. On a bar graph, it's important that each bar has the same width. Also, there's a space between the bars. They can be vertical, they can be horizontal. They're good for making comparisons of sizes of categories. All right, some things to be careful of. Beware the pictogram. So sometimes people like to add pretty pictures to, their bar charts. Like they like to make their bars into pretty pictures, which is not always smart. So bar graphs compare several quantities, and you're comparing them by looking at the different heights of each bar. When all the bars have the same height or the same width, then the area kind of looks more proportional. But when you're making something that isn't a bar, so let's say it's a picture, when you're trying to make the picture taller in order to keep the picture to scale, you mess up its width a little bit, you change the width. So now they have different widths and they can make something look bigger than it actually is. They make a value look larger than it actually is. So avoid doing that. Like always just leave at the bars. I know it's boring, but they're easier to read. And here's an example I'll show you. All right, here we're comparing vacuum companies. So Dyson's ad is claiming that their vacuum has more than twice the suction of any other vacuum. So they're showing, so this one up here would be the Dyson. Now, the way that their picture, though, they're making it seem like it's so much more with this picture because in order to keep the scale right, when you're making the vacuums taller, you make the width bigger. So this one has a much larger width than these two. Whereas if you're looking at it with a bar chart, it would look cleaner. It would not make it seem like there's such a big difference between the different vacuums. The last graph in this chapter is a line graph. So quantitative variables are sometimes good or sometimes measured over time. So to display how, a quantitative variable changes over time, that's when we use our line graph. So we put the time on the horizontal axis, we put the variable that we're measuring on the vertical axis, and we typically plot our points and connect them with a line. Here is an example of a line graph. So it's looking at how unemployment has changed over time. And so we start in 2008. And so you see, like in 2008, we've got like the people who, it kind of compares 4 different education levels. So you have the students that were people that got a less than a high school degree. You see them up here in this black line. The blue line down here, the bachelor's degree. Only the high school degree kind of up there, the some college. So you see the different lines. And we have our time along the bottom, and then our count or whatever it is that we're measuring. In this case, it's percentage of unemployment. So we're measuring that on our vertical axis. So we would plot our points. So like if we went over to 2010 and we found that people with bachelor's degree, about 4% were unemployed. So we would have our dot, and pretty much we would just kind of connect our line and go through. In this case, we see that employment, at least from, it kind of spiked over around 2008, 2009, 10, 11, it kind of started to come down. 12, it came down some more, and it's kind of lower than the rest in 2018. So you're looking for patterns when you describe these. That's actually on our next slide. So describing line graphs, you look for an overall pattern or a trend. A trend is just a long-term upward or downward movement over time. So we can look at this graph and over time we say, all right, a pattern, unemployment rates have gone down. Look for striking deviations next. So one striking deviation we can say is, wow, in 2009, from 2008 to 2009, unemployment rates spiked up, like they went up pretty high. Patterns that repeat itself at known intervals are called seasonal variation. I always compare those to like shopping. If you're measuring, sales of a certain store, maybe, around November, December, that store is making more money because, it's Christmas time and people shop more during Christmas time, buying Christmas presents and such. So that would be kind of an example of that seasonal variation where maybe that store would have higher sales rate during Christmas time than they would during other times of the year. You also want to make sure you watch out for your scales. If you notice, these two graphs are the same exact graph. The first one just goes up, your years are increasing by 5 years. The second one is increasing by 10 years. Also on your y-axis, your scale, there's a bigger gap between like 7,000, 8,000. There's bigger gaps there between the numbers. It makes the data look different. So it makes it look like in the second graph, it looks like we have a sharp increase of unmarried couples. Whereas if you look at the first one, you see it's a more gradual increase. All right, this last little graph, this shows the rise in college education, and it's specifically looking at women. So it's the percentage of women with college degrees. I don't like this graph because of the pictures. Things like pictures can make it confusing. They just add extra, extra stuff we don't need. So for this one, get rid of those pictures. Also, what I would add is, we didn't really give a scale on our vertical axis. So make sure, always want to make sure that's there as well.